Welcome, future mathematicians. Here we are back again. This video is going to be about section 1.2. Specifically, we're going to talk about um, a few things. We're going to look at going from words to graphs and graphs to words. Okay, so in this first part, I want to go from graphs to words, and I'm going to try to make it as quick as possible. We got to hit those notes again. So we want to make sure that we're writing what's a parent graph, what are those critical values, vertex, points of inflection, that kind of thing, and our domain and range. Okay, so for the first one here, we have that graph again. We already know it's domain and range from the last video, from the domain and range video, but let's see if we can figure out everything. So the other parts is the parent graph. So hopefully by now we've done a ring of fire. If we haven't, take a look back again at those parent functions. This one's going to be we're going to write an f of x is equal to x squared. Okay, so that's going to be our parent function. Our vertex is right here. Okay, so our original parent function, we can draw a quick sketch here. Excuse my shaky hand. This one moved. It looks like it moved 3 over, or translated, I should say, 3 to the right and 2 up. Okay, so if we just have a graph, we can actually take that parent function, take this parent function here, and make it a new graph. So I'm going to call this red section. We're going to actually call it a so this graph in red. Oh, actually, let's call it something else. Let's call it g of x for this translation. I know I have this kind of setup, x squared, but this time I'm moving or translating this vertex here 3 to the right. So I'm going to say I know this is a 3, and I'm going 3 to the right, so that's subtraction. Again, check your notes if you don't remember. Pluses actually move it to the left. And then I know I move it up, so I add 2. So there is my new function. This red one here is going to be g of x, and it's going to look like this. Okay, so again, domain and range was from the last video. If you don't remember, I guess I could write it again. So domain and range is going to be domain, how far left and right can I move? Well, I can go from negative infinity all the way to infinity. And range is going to be a little bit different. Oops. Range is going to go down. The most, or the lowest I can go is going to be like a 2. So I'm going to put a 2, comma, and the highest I can go is infinity, like that. And notice again that this side has a square bracket because I am including the number 2, but I can't include the number infinity because there's always an infinity plus 1. So I think that'll be it for this video. I might come up with more examples, but we'll see. Until next time, thanks. So one more thing I have to add is I forgot to mention that we need to talk about critical points. So we might be talking about vertexes in this case, points of inflection. So a vertex on this one would be right there. Another vertex would be right there. So the green, remember, is the parent function, and we're going to talk about moving the vertex over or translating it, right? So in this case, my vertex is going to be translated to 3, comma 2. So I'm translating my vertex from the origin to 3, 3, 2.